ladies and gentlemen. This is how to hook up a NEMA23 stepper driver motor to a MySweety little microstep driver. The MySweety is a little 4-amp jobber. They're less than $10 on eBay or Amazon, or some of the other vendors also sell them, Kiji, and I'm sure there's quite a few others that I'm not aware of. But basically I got this thing wired up right now to run in a kind of a low speed condition. And this would probably be suitable for all kinds of different operations, completely adjustable. The only problem is that most of the time, if you're over half of the speed of the motor, you have to turn the potentiometer all the way back to zero. The potentiometer basically leaves it wherever it left off the last time. It is nice. It does have a reversing function, but that also sometimes too, if the motor is more than half of the speed at whatever given setting, sometimes the reverse function, it will oversaturate the motor, and you would have to turn it down to the lowest speed in order for the motor to do its reversing action. I'll give you an example of that. We're going to start this motor slow speed. We're a little bit better than half of the speed of the motor. It locks up because the motor is saturated, so you have to turn it off, turn the motor down. Now if you're just barely moving or whatever, the motor will turn backwards and forwards. It doesn't really matter. It's when you start getting, see, even there, it's at a moderate speed and it'll still reverse, but once you start hearing a large frequency change, it locks up because the level of power is going through the motor is just saturated the coils, and it will lock the rotor up. Short of that, there is a couple of things that you can do to customize where the motor's speed range is and all of that, but we'll get to that after we tell you how to wire this thing up. Starting from left to right, we have a 110 volt power cord. For demonstration purposes, I put a little rocker switch in it just to cut the power. Anytime I have a live line going, I like to be able to cut the power some way other than just unplugging it, but just unplugging it's okay too. We have the line connection, which would be the black lead, goes all the way to the left. By the way, this is a 24 volt power supply. The MySweety will take anything from a 9 to 40 volt DC power supply. I wouldn't run it on 9 volts unless that's the only thing you have. The closer you get to 20 or 40 volts, the better off you're going to be for efficiency and whatnot. But depending on what you're running, a 9 volt power supply may power you just fine if you have a very low demand, or you have a NEMA23 motor. This drive will also turn a NEMA23 motor, and you'd have no problems there at all. But since this is a NEMA23, we're going to go ahead and give it 24 volts. Back to where we were. We had the neutral connection was here, a ground for the 110 volt circuit. Now internally, coming out of here, we have the 24 volt negative, 24 volt negative, 24 volt positive, 24 volt positive, and there's two separate outputs on this, but either one of them will work. So what we got going on here, we have the black wire here is the negative for the 24 volt circuit. I've given it to the ground lug of the MySweety, as well as the ground lug on the pulse generator. Now this pulse generator kind of acts like a fake computer in a way. What it does is it gives a pulsing signal to this micro step driver. The pulses are then turned into motor motion through the action of the card and how you have the dip switches set, coupled with the setting of the potentiometer and a couple other factors. It gives you the motor speed. So from there, we also made the power connection from the 24 volt power supply to the VCC terminal of the MySweety, as well as the positive terminal of the board. Luckily the board will take up to 24 volts, so this little pulse generator will handle 24 volts. That's why I chose the 24 volt system. It just makes things convenient. Otherwise you'd have to have another power supply for the lower voltage or some type of resistor or resistor circuit. Okay, from there we're going to go ahead and tell you the motor leads. Now I looked on Amazon for the NEMA23, and how they have it hooked up to the MySweety is incorrect. Your results may or may not differ, but this is the way that I wired it up to get the best results. A positive was identified as blue, but on this particular motor, A positive is red. A negative will be blue. The B positive is green. The black negative, or the B negative is black, excuse me. That is for the NEMA23, just to say it without screwing this up. Black, blue, green, black. That is an ascending order from the A terminal up to B minus. That is the motor connections. Okay. After the motor connections, we're going to make these board connections here. You could start however you liked. I started with the brown wire here, which is the pulse side of it, the pulse positive. From the pulse positive, which is the uppermost terminal or the rightmost terminal, depending on how you're looking at this, that will be the pulse positive. This actually sends the pulse to the generator. So that will be on the pulse positive. It gives a 5 volt signal. Okay. Well, luckily enough with this MySweety, to open up the other gates on this, we're going to be jumping these terminals, and it jumps from the pulse positive to the drive DIR positive, as well as from the drive positive to the ENA terminal, and that is going to supply all of the power for those functions. Now, depending on what dip switches you got flipped and all that, will determine the output to the motor. From there, we're going to end up, so we made all the positive connections to the MySweety. Now we're going to come back with the negative connections that have to go back to this board. You can start it off however you want. It's 3 wires basically. The first one that I did was the EN negative, so that is this white wire without any marks on it. That will go to the corresponding EN tab on the pulse generator. Coming back to the DIR negative, I didn't have another color, so I just put some splotches on this black wire, but on the board it is also marked DIR, so that was quite easy. Coming back to the next one, this is the pulse negative. That one I used as green. You could use any other color that you want. Funny enough, though, on this board, it's not written as pulse. It's written as CLK for reasons that I don't know or understand. Maybe somebody else has an answer for it or whatever. But basically, that completes the setup of this board. Now, there's a whole bunch of different things that you could do to get speed and torque and all kinds of different stuff out of this, and I can't pretend to know exactly what you guys are going to use this for or whatever, but the reason why I'm making in this video is for a relatively low speed operation for a specialty type of sharpener. So we're going to want something that is in the anywhere from 300 to 600 RPM range. I can't imagine needing anything faster than that. So we're going to set this thing up for a relatively low speed operation here, and probably the best way of doing that is probably just SW1 will be turned on, and right now I have just SW1 turned on. So with this, just SW1 turned on, you know, I gotta guess it's probably in the neighborhood of 600, maybe 700 RPMs. I can't imagine being any more than that, but we can set this up to SW1 being on as well as SW3 being on, and that is actually a very useful mode as well. And I will flip this switch if I can get it to agree with me, and we'll test that out. Okay, now the frequency is a little bit higher, so you will get a little bit higher speed on this, but still usable for a lot of different things. Probably a little bit too fast for a sharpener, but if you have a honing device or something to that effect, you could probably get away with that. Me personally, I mean, I like the just the SW1 by itself. It's a pretty decent speed, you know, even on the top end of it. The only pain in the butt is that you do have to turn it all the way down, or down to half speed anyways, for it to fire up again in the same thing. But anyways, if there are questions or needs for clarification or anything like that, I'm happy to help out. Thanks for watching this.